Good day to everyone. I am Mr. Philip D. Heneta from the College of Industrial Technology of Batangas State University, and I am going to present our research entitled Development of Arduino-based Decibel Meter for Mufflers. My co-researchers are Sam David Amada, Ronald Mendoza, and Georgie Andrea Sastrillo. The contents of my presentation include introduction, materials and methods, results and discussions, and conclusions. Introduction. The continuous development of technology and innovation paved the way to advancement and improvement, which also served as a vast change in all aspects of human life. A combination of these was generally used to gain upgrades and resolve issues that exist in the community. Presently, this also replaced and changed customary methods for getting things done. It is undeniably true that technology is already part of the society. According to a study of Asian Development Bank, the growing sound pollution can be attributed to a large part from the millions of three-wheeled vehicles and two-wheeled vehicles roaring through the streets and neighborhoods. The study aimed to indicate that the modified mufflers emitted by tricycles and motorcycles manufacture noise levels as high as 97 decibels, means too loud for the national standard of 60 decibels. Meanwhile, Senator Win Gatchalian filed the Muffler Act of 2016 on November 2, 2016, which prohibits the use of modified mufflers to enhance the sound output of vehicles. The bill seeks to ban motor vehicles, motorcycles, motorbikes, scooters, and tricycles to use any form of modified mufflers, sound boosters, or any device which will increase the sound output higher than 70 decibels. The only exceptions to this bill were the vehicles for motor shows and professional racing. To address this problem, different laws were made and imposed by the government. Conducting checkpoints for motor vehicles in order to apprehend the violators in the municipality were done in Rosario and other municipalities. However, this serious problem has been mostly ignored, but requires serious attention and action to avoid more serious problems. Therefore, the proponents came up with the idea of Arduino-based decibel meter for mufflers as a means to solve this existing dilemma. The general objective of the study was to develop an Arduino-based decibel meter for mufflers. Specifically, the study aimed to first, design an Arduino-based decibel meter for mufflers which is capable of measuring the sound level or noise of a motorcycle muffler, capturing the plate number of the motorcycle being tested, and sending the result received via Bluetooth to the authorized law enforcement agency. Fabricate the Arduino-based decibel meter for mufflers using locally available materials such as Arduino Nano microcontroller, sensors, Bluetooth module, serial camera, and battery. Third, to test and improve the developed prototype using accuracy test and functionality test. And then the last one is to evaluate the performance of the device in terms of quality, user interface design, safety, functionality, and economy. So for the materials and method, the researchers used the developmental type of research to conduct this study. Developmental research involves the systematic study of designing, developing, and evaluating programs, processes, and products. This approach employed thorough planning and analysis to develop the project, and then the conceptual model as illustrated in Figure 1 shows the different blocks significant in achieving the objectives of the study. The input block is composed of the knowledge requirements, hardware requirements, and then the software requirements. For the process block, here are the following steps: design, construct, test and improve, and then evaluate. And then the output is the Arduino-based decibel meter for mufflers. So this section provides the project design. Figure 2 shows the layout of the project. The front view, back view, and then the bottom view of the prototype. So Figure 3 shows the interconnection of the project components. The figure illustrates the interconnection of the different components of the project, such as the Arduino Nano, sound sensor, serial camera, Bluetooth module, SMS module, battery, and the switch. So for the results and discussions, the Arduino-based Decibel Meter for Muffler was developed to mobilize the roadside operations of the LTO and LGUs in controlling the noise pollution emitted by motor vehicles with modified and defective mufflers. Locally available materials were used in the fabrication of the prototype, such as Arduino Nano microcontroller, sound sensor, serial camera, SD card module, and HC-05 Bluetooth module. It has a mobile application that was developed using BASIC for Android software. So figure 4 shows the completed project. So it has a serial camera, sound sensor mounted on the microcontroller and then enclosed in the casing. It has also a charger port and switch to turn on and off the device. So figure 5, here are the sample screenshots of the mobile application of the decibel meter. The figure on the left shows the connection screen wherein the user or operator will choose the HC-05 to connect with the device. And then the middle figure shows the menu screen. The screen should display all the hardware status in order to continue. It has a start button to begin measuring. The figure on the right shows the screen wherein the plate number of the motorcycle being tested is entered. The location field is automatically detected, showing the coordinates. The user can press the start button, then the sound level meter will deflect depending on the noise detected from the vehicle. It has view logs, button, and settings for generation of report purposes. So table 1 shows the accuracy test result. So the table shows the comparison of the results obtained from the sound level meter and the Arduino-based decibel meter for mufflers. The results of the sound level meter were then compared to the results obtained from the prototype. This way, the researchers are able to see whether the prototype is accurate or not. After comparison, the test proved that the results given by the prototype are accurate and reliable. 6 motorcycles were subjected to this test and found out that the accuracy of the device was 96% accurate. So for table 2, the functionality test result. So this figure shows the actual photo taken by the serial camera, and then the last column shows the SMS sent by the device. So the SMS contains information such as plate number of the motorcycle being tested, its location or coordinates, and the value in decibel. So here is the result for test number 2 of the functionality test result. Test number 3, test number 4. So 4 motorcycles were subjected to this test. So the serial camera and then the Bluetooth module were found to be functional. So for the evaluation result, the developed prototype was evaluated by 20 respondents composed of 10 technical experts and 10 end users using the evaluation form with the following criteria: quality, user interface design, safety, functionality, and economy. Table 3 shows the results of the evaluation. So based on the evaluation results, the functionality gained the highest mean score of 4.59 with a descriptive rating of excellent. This indicates that the prototype works as designed and expected. It was easy to operate and provides convenience to both the user and the operator. So meanwhile, the overall mean score of the developed prototype is 4.47 and its descriptive rating is excellent. This indicates that the evaluators were satisfied of the outcomes and capabilities of the device. Conclusions. The Arduino-based Decibel Meter for mufflers was successfully designed to measure the sound level or noise of a motorcycle muffler, capture the plate number of the motorcycle being tested, and send the result received via Bluetooth to the authorized law enforcement agency. The Arduino-based Decibel Meter for mufflers was fabricated using locally available materials such as Arduino Nano microcontroller, sound sensor, serial camera, SMS module, and Bluetooth module. The developed prototype was tested and improved using accuracy and functionality tests. And then the last one is that the performance of the prototype was rated excellent with an overall mean score of 4.47 by experts and possible end users based on the results of the evaluation conducted. So that's it. Thank you.